Hey guys, Mr. Martin back here again with today's video on how to apply triangle sum properties. Let's get started. Before we talk about the triangle sum properties, let's talk about what is a triangle. Everyone knows the definition of a triangle is a polygon with three sides. But oftentimes we forget there's actually a better definition. A better definition is a polygon with three angles, because that's literally what triangle means. Tri meaning three, angle. A triangle also has three angles. We always think about the sides, but this video is going to have a lot to do with the actual angles. Alright? When we name a triangle, we name the triangle using its vertices. So for example, a triangle with vertices A, B, and C is simply called triangle ABC. Or for shorthand, we can write a triangle, or draw a triangle, and then the letters A, B, C, which represent the vertices. Okay, so let's move on and talk about some of the ways to classify triangles. The first way to classify triangles is by their sides. So if we have three sides that are not congruent to each other, in other words, no two sides are the same length, then we call that triangle a scalene triangle. Okay? The second way to classify triangles by sides is if there is at least two congruent sides. Okay? In this case, that side and that side are congruent to each other. So we call that, with at least two congruent sides, an isosceles triangle. Okay? And then the last way is by having three congruent sides. And this time we'll call that an equilateral triangle. That literally means equal sides. Alright? Let's look at classifying triangles a second way. Classify triangles by their angles. Okay, so we all know triangles have three angles. If all three angles are acute angles, meaning that all three angles are less than 90 degrees, then we call that an acute triangle because of the acute angles. If one of the angles equals 90 degrees, then it's a right angle and we call it a right triangle. If one of the angles is an obtuse angle, meaning greater than 90 degrees, then we call that a, yep, you guessed it, obtuse triangle. Okay? What about if all three angles are the same? Then we call that equal angular. Okay? Equal angular literally meaning equal angles. Just like equilateral meaning equal sides. Alright, let's see these angles in the triangle. If we take those three and we extend the sides, we make other angles. Okay? We have angles that are inside the triangle, angles of the triangle. Those are the angles that are used to define this as being a triangle. It's got three angles. Those are the interior angles. Okay? Now when we extend the sides, we get what's called angles. Okay? The angles that form linear pairs with the interior angles are what we call exterior angles. So in this picture, if we draw an interior angle right here, you can see there's actually angles that form a linear pair. Okay? And we know by vertical angles, those two angles actually are congruent to each other. And they're also congruent to each other because we know that any angles that are supplementary to the same angle are also congruent to each other. Okay? Even though we have two exterior angles on each vertex, it's to use one of those exterior angles on each vertex. So for example, if we were going to use this exterior angle here, okay, then we would move to the next vertex and we'd use the non-consecutive angle. That would be the exterior angle there. Okay? And then we'd move to the next vertex and the non-consecutive angle would be the exterior angle. And there would be three exterior angles there. Okay? So those are the three exterior angles, and then of course we have the three interior angles. So let's talk exterior and internal angles, or interior angles. The first theorem is called the triangle sum theorem. This theorem is pretty simple. It simply says that the sum of the measures of the interior angles in this case, angle A, angle B, and angle C, the sum of the interior angles of a triangle is 180 degrees. So if you were to add up all three of those angles, you would get 180 degrees. Now that is true for every triangle. Okay? Doesn't matter if it's an acute triangle, a right triangle, an equal angular triangle, or an obtuse triangle. All triangles have an interior angle sum of 180 degrees. Let's look at a proof of this theorem. Okay? Sometimes when we use a diagram in a proof, we want to add a line, a segment, or a ray to the given diagram. We're going to do that in the proof of the triangle sum theorem. We're going to add an auxiliary line to the diagram. So let's look at that auxiliary line drawn in there. Can you see line BD is parallel to line or segment AC? So this line right here is parallel. Okay, notice the arrows on it to the base of that triangle. And we know from the parallel postulate that through any given point there is exactly one line that's parallel to the given line. So if you think about AC as being part of that side, being part of a line, okay, then there is only one line that's going to be parallel to that given line. Okay? That's from the parallel postulate. It's the same postulate when we were talking about there being just one perpendicular line through the given point, perpendicular to the given line. Okay? Alright, so let's make a plan for this thing. I think you can see that angles 4, 2, and 5 all make a straight angle. So they all have a measure when added together of 180 degrees. Remember what we're trying to prove. We're trying to prove that the interior angles are 180 degrees. So having three angles that already equal 180 I think are going to be helpful. Okay? We also have, because we realize that there are parallel lines cut by a transversal, we also have alternate interior angles that are congruent to each other. So 1 is congruent to 4 and 5 is congruent to 3. So I think you can see that if we can take out angle 5 and put in angle 3, and take out angle 4 and put in angle 1, we'll have a set of angles that will add up to be 180 degrees. Okay, so that's going to be our plan. We're going to draw an auxiliary line. We're going to show that those three angles at the top add up to be 180 degrees. And then we're going to substitute in angle 1 for angle 4 and angle 3 in for angle 5. Okay? So here we go. Okay. So we draw the parallel line. We know there's only one thanks to the parallel postulate. We know that measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 is 180 degrees. We know that 1 is congruent to 4 and 3 is congruent to 5. Okay? And we know because they're congruent to each other, their measures have to be equal. And we're going to substitute. We have 1 being congruent to 4, so we're going to take out 4 and we're going to put in 1. And we have 3 congruent to 5, so we're going to take out 5 and we're going to put in 3. And that's going to give us the theorem that we wanted, that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, which are the interior angles of that triangle, have to add up to be 180. Okay, so jot down the proof. Pretty simple proof, I think, using postulates and theorems that we've already learned from previous units. Okay? Alright, let's go on. Just a couple more things to talk about. Let's look at the exterior angle theorem. That one was, before this was called the interior angle theorem. Let's look at the exterior angle theorem. Okay? This theorem I think also makes common sense as well, because we're going to show that by a proof the exterior angle, when we extend side AC, the exterior angle right there, it's going to be equal in measure to the sum of the two non-adjacent interior angles. So right here we've got the adjacent interior angle. We're not going to use that angle. We're going to use the two non-adjacent interior angles, which are going to be namely angle B and angle A. So, if we add up the measure of angle BAC to the measure of angle ABC, we are going to show that we get the measure of angle BCD. Okay? Alright, so here we go. Let's do a paragraph proof this time. We did the last time. Let's do a paragraph proof this time. Alright? So we're going to start off by saying that, let's start off by saying that the measure of angle, let's call it angle BCA, plus the measure of angle BCD equals 180 degrees, and we know that's true because they are a linear pair. Okay? Then, from the interior angle theorem, we know that the measure of angle BAC plus the measure of angle ABC plus the measure of angle BCA has to also equal 180 degrees. We just learned that from the interior angle theorem. The interior angles of a triangle add up to be 180 degrees. So now we've got two statements here that are both equal to 180 degrees. Okay? So let's take those two statements and let's set them equal to each other. So we're going to say, by using the transitive property, okay, we can say that the measure of angle BAC plus the measure of angle ABC plus the measure of angle BCA, the interior angles, has to equal the measure of angle BCA plus the measure of angle BCD, which are those angles that were formed from the exterior angle and the interior angle that were the linear pair. Okay? So now I think you can see we've got angle, what's on both sides? I see angle BCA on this side, and I see angle BCA on this side. So I'm going to, that's right, subtract that angle from both sides. All right, let's move on to the last thing I want to talk about. Last things I want to introduce you to what's called a corollary. A corollary to a theorem is a statement that can be proven easily using the theorem. So the corollary that we're going to use today is the corollary to the triangle sum theorem. Remember, the triangle sum theorem says that the interior angles of a triangle add up to be 180 degrees. So what if one of those interior angles was a right angle? Or in other words, what if one of those interior angles measured 90 degrees? So we know from the triangle sum theorem that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. But what if the measure of angle C was 90? Well, let's substitute that in. And I think you can see that I can subtract 90 from both sides. And I'll get the measure of angle A plus the measure of angle B has to equal 90 degrees. What that simply says, guys, is that the other two angles in a right triangle have to be complementary. That's a pretty easy theorem, and that falls out of the interior angle sum theorem. In other words, we can use the interior angle sum theorem to just modify it a tad, and now we've got the two non-right angles of a right triangle being complementary. So pretty easy, kind of, let's say that's a consequence that falls naturally from the triangle sum theorem. All right, so you get all these theorems down in your notes and be ready to practice using these theorems in class. We'll see you in class, guys. Have a great day.